Hey guys, this is section 3.6. I'm on page 284 and we're just continuing on with the section. So now we're going to look at some applications. So part of the approach with this particular section is assuming that maybe you don't know all this stuff about quadratics. So even though we're talking about solving equations, it's kind of hard to solve equations if you know nothing about the type of kind of equation that you're working with. So we're trying to get used to that, and one way that we do that is with applications. So let's read example 5. A ball is thrown upward from a cliff that is 30 feet above the ground. This situation can be modeled by this quadratic equation. What does h of t represent, and what do you think t stands for in this situation? So I haven't told you what these mean, but just by kind of looking at this. So we're throwing a ball off of a cliff. So maybe here's my cliff, and here I am, and I'm throwing a ball off of a cliff. So this equation is modeling this. So the question is, what does h of t represent? Well, it's probably representing how far it is above the ground, because we want this equation is modeling how far really, or where it is above the ground. So now what about t? What does t represent? This can be a little bit trickier, but if you think about this, this is talking about the height changes as time goes on. So t represents time, and this will happen pretty quick, so I'll just tell you that it represents time in seconds. Okay, so the second question here is, what is the maximum height that the ball achieves in this situation? So I want you to notice the word here. The key word here is maximum. So we're talking about a maximum, and if I go back to this equation, this is a quadratic equation, right? So it will have, so now we have to think about, will it have a maximum? Does that make sense? Well, first, think about, what is the leading coefficient? The leading coefficient is -32. So since it's negative, that means that this will have a maximum, and that's what this is asking for, right? This is really asking for the vertex. So I just need to find then the vertex of this, and I can do that using the vertex formula. So then, what is my A? My A is -32, and my B is 64. So now I can just plug all of this in, this -b over 2a. So I'm going to go ahead and tell you guys to pause here and try to figure this out. Hit play when you're ready. So I'm going to plug in everything here, and ultimately this becomes really just 64 over 64, so this equals 1. So now I have to plug 1 into my function. So if I go back to this, I need to find h of 1 in this case. So I'm just going to plug in 1 into all of these parts. And so this is -32 plus 64 plus 30. So what does that equal? This will ultimately equal 62. But this is in the context now of a application problem, so 62 is not a good enough answer, so now we have to go back and kind of read this. So this height, we actually never mentioned this. What is the unit for this height? In reading this back over, this is talking about 30 feet, so h of t represents how far the ball is above the ground in feet. Okay, so if I'm asking what is the maximum height, then I would say the ball will achieve this maximum height of 62 feet. And just to show you this in our picture, so remember, we're throwing the ball into the air up like this, and then it comes back down. So we're talking about its maximum height will be somewhere, I don't know, somewhere up here, something like that. Okay, so let's take a look at one other application here, and this one's a little bit trickier. So Sherry has 300 feet of fencing and wants to enclose a rectangular plot that borders on a river. If she does not fence the side along the river, find the length and width of the plot that will maximize the area. What is the largest area that can be enclosed? So you're probably wondering, what does this have to do with quadratics or anything else that we've been talking about? So I want to point out a key word here, the word maximize. So this is kind of indicating to me that there must be something quadratic about this, and we're going to have to figure out what that is. So let's take this down in pieces. It says draw a picture of this situation and label the sides. So I have a fence, and I want to have it enclose this fence, but it's going to border a river. So basically, here's my river, and then here's my fence. So I don't need fence on the part that's actually bordering on the river. So now I want to label the sides. What should we call these sides? Why don't we call this side W, and we'll call this side L, and we'll call this side W. Okay, so if I wanted to figure out the area of this, in general, what would be the area for this shape here? Don't let the river kind of throw you off. You could think of it just really as a straight line if you wanted to. So maybe here's my river here. Okay, well, in general, for a square or a rectangle, we would have my area is equal L times W, length times width, right? So this models my area, but now what I need to do is I also need to consider one other thing about this. I need to consider the perimeter, which I probably want to spell that out here. So what is the perimeter of this? So just the fencing area. How do I find that perimeter? Well, you find perimeter by adding up all the sides. So if I add up the sides, this is W plus W plus L. Now, what do I know about the perimeter? Well, the perimeter is really based off of how much fencing I have. And how much fencing do I have? I have 300 feet of fencing. So all of this has to add up to 300 feet. And I can rewrite this as 2W plus L equals 300. Okay, so now what I want to do is I want to kind of relate this thing here to my area equation. So I want to try to see how can I relate these two things. And I can do that if I take a look at this equation a little bit closer. You know, you have two letters here, but one is very easy to solve for. Which one's easier to solve for, W or L? The L is easier to solve for, so I want you to notice what happens when I do that. Let me solve for L by subtracting my 2W. Then my L will be 300 minus 2W. So now that I know this, I can actually relate this back into my area equation. So what I mean is, where I see an L here in my area, I can now replace that with this new relationship that I've found here. So I'm now going to write this as not just L times W, but now I'm going to replace it with that new equation. This is 300 minus 2W times W. And what happens if I actually multiply this out? This becomes 300W minus 2W squared. Okay, so I found kind of a way to make my perimeter and my area. I found some way to kind of relate those two things. And now I've found this structure of my area equation. And so I just want you to look at this equation for a second. What kind of equation is this? It has a W squared, so it is a quadratic equation. So this is quadratic. Now, since it's quadratic, I would like to write it so that the squared term comes first. So I want to rewrite this one more time. Let's rewrite this as 2W squared plus 300W. Okay, so this is quadratic, and what do you notice about the leading coefficient? The leading coefficient is -2, so does this have a maximum or a minimum? Since it has a negative leading coefficient, it will have a maximum, and that is what we were asked to do at the beginning of this, right? We were asked up here to maximize. So we now just have to figure out what is the maximum of this. And the maximum is just found by figuring out what the vertex is. So now the next part of this is really I need to figure out the vertex. So in looking at this, what is my A and what is my B? My A in this case is -2, and my B is 300. So now I can just plug this in. I'm going to plug this into my vertex formula. -b over 2a, and this becomes -300 over 2 times -2. And ultimately this will equal 75. Now I have to plug 75 back into this area equation up here. So I'm running out of some space here, but I can do this. So this is -2 times 75 squared plus 300 times 75. So this will turn into -11,250 plus 22,500, which if I add those together, I get just back to 11,000, positive 11,250. And so here it is. Here's the maximum amount of area. So this would be 11,250 feet squared is the maximum area. Now, the last question says, what are the dimensions of this plot? So now I've figured out all of this information. So I had this 75 here. And remember, I plugged it into my area equation. I plugged it in for W. So what that means is my W is equal to 75. And then to figure out my length, now I have to go back to some work we did earlier. We found that L was equal to 300 minus 2W. So if I just plug this in, I will get that my length is 150, and you're going to want to include the units on this. Okay, so I know that's always a little bit exhausting to go through the word problems, so I think this is a good place to stop, and I'll see you guys in the next video.